Hello everyone, thank you for joining us for this introduction to Tableau Public workshop for MBA students. Tableau is business intelligence software. It is designed to create web-based interactive data visualizations. It has a very intuitive user interface. Its drag and drop, select and click feature enable technical and non-technical users to quickly create cross-tab, text table, line chart, bar chart, maps, all kinds of data visualizations. That means you have quick production time. The goals for this workshop are to learn Tableau product suites and learn how Tableau Public works and its basic workflow. There are two parts for this workshop. The first part is a brief presentation on Tableau Public. The second part is to use sample superstore data with hands-on activities to learn the basic workflow of using Tableau Public. Here are Tableau products. The applications on the top row are for personal use. The main application is Tableau Desktop. It's for your data analysis project. Tableau Prep is kind of like an assistant program. It's designed to help you clean data, reformat data, and combine data. Data preparation is an integral part for your data analysis project. Once your data is well prepared, you can start your data analysis faster. Also, once your data is well prepared, your data analysis can be more accurate and more meaningful. Tableau Reader is a read-only application. It's free. You can open any project file saved with Tableau Desktop. Tableau Server and Tableau Online at the bottom row are for organizational use. If an organization wants to have a Tableau server, the organization will need to buy it and have people to maintain it. Tableau Online is kind of like a cloud solution for Tableau Server. It's kind of like subscription-based service. Today we are going to use Tableau Public. It's free. It's a free solution service offered by Tableau Company. In order to use Tableau Public, you will need to use both Tableau Desktop and Tableau Server, just the Public Edition though. Once again, in order to use Tableau Public, you need to download and install Tableau Desktop, the Public Edition, on your local computer. You also need to create an account on Tableau Public server because there are limitations for using Tableau Public. The main limitation is that you cannot save any work locally. You can only save your work to the Tableau Public server. There are other limitations like connection to data sources are limited to static data files. Your storage on Tableau Public server is limited to 10 GB. Still, the major limitation is you cannot save any work locally. This introduces concerns for security for your data. Once your work is saved, published to the Tableau Public server, the Viz is open to everyone. The Viz refers to any work you created, such as text table, line chart, bar chart, map, dashboard, story. This will be open to everyone who has internet access. Although the underlying data can be protected, it is still not recommended that you save, publish any sensitive or confidential data to the Tableau Public server. If you do work with sensitive or confidential data, you may want to remove that part before saving your work to the Tableau Public server. In addition to Tableau Public, Tableau Company also has Tableau academic programs. That means students and instructors can get 1 year free academic license for both Tableau Desktop and Tableau Prep. And then you can renew that license on a yearly basis if you are still qualified as a student or an instructor. And with academic license, the Tableau Desktop and Tableau Prep application you are able to download and install on your local computer. They are full applications. This is the diagram for data visualization workflow with Tableau. First, you need to connect your data. With Tableau Desktop, the full version, you are able to connect to static files such as CSV file, Excel file, JSON file, a bunch of static files. You're able to connect to traditional relational database, cube database, database in cloud, or just public data on the web pages. Once data is connected, you can start your data analysis process. You can create basic bar chart, line chart, scatter plot with worksheet. Once you have multiple worksheets created, you can put them together to build interactive dashboards. A dashboard is a collection of worksheets. It allows you to view, monitor, and compare more data at one place. And then at last, you want to save and share your work. You can save it locally, or you can save it to Tableau server, or you can save it to Tableau Public server. We're going to use Tableau Public today. In terms of connection, you're limited to connect to static files. In terms of analysis, there's no difference between the full version and the free public version. In terms of saving, sharing your work, you are limited to save your work to the Tableau Public server. We will come back to this slide at the end of this workshop. Before we get started on the hands-on part, I want to show you a few Tableau data visualization examples. They are local examples. Go to Rice University Office of Institutional Effectiveness. On its homepage, you will see institutional research reports. Under student admissions, if I click on undergraduate admission statistics. So this is a typical bar chart. At the lower left corner, you will see Tableau logo. And when you mouse over it, it says go to Tableau Public. If I click on that link, it takes me to the Tableau Public website. So this viz was originally first published on the Tableau Public server and then embedded to this website. So this is a typical bar chart. Go back to this page. If you click on student enrollment and click on this data visualization, similarly, you will see the same Tableau logo, and this was first published on the Tableau Public server, and then it's embedded to its website. So as I mentioned, Tableau is designed to create web-based data visualizations. So this is a dashboard. The dashboard is made of 2 worksheets. The top is a text table. At the bottom is a pie chart. On the left-hand side, there are 3 interactive filters. If I select, say, 2019, and you will see both the text table and the pie chart have been filtered accordingly. Similarly, for the program level, if I uncheck all and choose Bachelor, then you will see both worksheets on this dashboard have been filtered properly. Back to this page. If we click on Alumni and click on this geographic distribution, you will see a map. The map shows the number of alumni for all the US states. These examples are not super fancy, but they serve their purposes very well. Hopefully by the end of this workshop, you can create typical charts like bar chart, line chart, text table. You can create dashboard with interactive filters. You can plot your geographic data on map. Specifically, in this workshop, we are going to see how to create a line chart, a bar chart, a stacked bar chart, a circle chart. We are going to talk about the built-in data hierarchy and how to create a custom data hierarchy, how to put together an interactive dashboard, and how to present your data analysis with Tableau's built-in story feature. If we have time, we are going to cover some advanced features that in general I cover in my intermediate Tableau workshop. That includes how to compare two measures in one chart with dual axis, how to create scatter plot, how to create a calculated field that does not exist in your original data source, how to apply quick table calculations. Let's preview the sample superstore data that we are going to work with. This Excel file has 3 sheets: orders, people, and returns. We are going to use orders sheet. The first row is column headers. The first few columns are qualitative data, descriptive data. Mainly, we are going to use order date, segment, state, product category, subcategory. The last few columns are numeric data, quantitative data. Mainly, we're going to use sales and profit. If I select a column, at the bottom, you will see the count of number of rows is 9995. The first row is column headers, so we know we have 9994 rows of data. Open Tableau Public. On the Tableau Public start page, on the left-hand side, you will see the data connection pane. The central area will list the recent projects you have been working on. The right pane listed links to various learning resources. For Tableau Public, you are pretty much limited to connect to static files. Click on Microsoft Excel. Navigate to where you have sample superstore data stored. Click to select it and open. On the data source page, on the left-hand side, we see the 3 sheets from this sample superstore Excel file. If the Excel file you work with only has 1 sheet, it will be automatically put in the canvas area. Since this sample superstore Excel file consists of 3 sheets, so we need to tell Tableau which sheet we need to work with. Drag orders to the canvas area. and drop it. Below the canvas area, we see two panes. The left one is table details. We see 21 fields with 9994 rows of data. That looks correct. We also see field names and field data type. You can just click on arrow to clap table details pane. So when data is connected, Tableau automatically does a lot of work for you. It tries its best to interpret the data. The first thing it does is to assign a data type for each field. Each column header is viewed as field. In other applications, it may be called variable, but in Tableau, it's called field. This automatic assignment of data type to each field may not be correct all the time. So you need to go through and make sure all the automatic assigned data types are correct, since that will affect how you can analyze your data. For instance, the first column is row ID. It contains all numbers, so the automatic data type assigned is number. Although row ID are all numbers, it makes more sense if the data type is string. So click on this drop-down menu and change it to string. And you will see all values have been left justified. In most applications, when numeric values are right justified, that means they have data type of number. When they are left justified, that means their data type is string. For order ID, we see the default data type is string. That's correct. For order date, the default data type is date. That's correct. So we look through all the automatic assigned data type. They all looks right. We scroll all the way to the end of the table and to see some quantitative fields like sales. The default data type is number, decimal. Profit, the default assigned data type is number, decimal. They all look correct. So click on sheet 1. We are ready to do our data analysis. So this is Tableau Desktop's workspace. On top, menu, and then toolbar. The sidebar contains data pane and analytics pane. Next to the sidebar, we have pages, filters, columns, and rows shelf. We also have marks card. These are places you can drag fields over to add more data to your view. The biggest area in the workspace is the view. This is where you create your visualizations or your visualizations are displayed. At the bottom, there are 3 buttons: worksheet, dashboard, and story. In the hands-on part, we are going to cover all these 3 buttons. Inside data pane, we see there's a horizontal line that split the fields into 2 groups. Above the line, they are called dimensions. Below the line, they are called measures. Dimensions are those fields that hold categorical data or qualitative data. Measures are the fields that hold numeric or quantitative data. So when data is connected, each field is assigned a data type, like string, date, number. Meanwhile, each field is also assigned a data row, whether it is a dimension or measure. Dimensions and measures are very important concepts. When you drag a dimension field or a measure field to the view to construct, to build your visualization, they behave very differently. But together, they build the visualization you want. We will see how they are different when we do the hands-on activities. Next, I'm going to use 3 to 5 minutes to quickly demonstrate how to use Tableau's drag and drop feature to create a text table and how to use this Show Me menu to convert that text table to a common chart type such as line chart, bar chart, or pie chart. So this is the view area. This is where you create a visualization. I will drag profit, which is a measure, to the view area. I got one number. When a measure field comes to the view, it is automatically aggregated. That's why we got one number. If we click on this drop-down menu, we see the automatic aggregation method applied is sum. We can choose different aggregation method like average, median, count, or others. So this is the sum of all values in the profit column in the data source. On the status bar, we see one mark. The status bar displays information about the current view. So this one number is called one mark. Tableau uses mark to display data. A mark can be a row of data in the original data source, or it can be a group of rows of data in the data source. This one number, the sum of profit across all rows in the profit column, is not super helpful or very informational. In general, we want to add date field to the view so we can view data changes over time. That means we can see data trend. So drag order date to rows. Now we see that one number has been split into 4 numbers. We have 4 marks on the status bar. Often, we want to group our data by some combination of categories so that we can compare data. If we drag category to columns, so that 4 numbers have been further split into 12 numbers. On the status bar, we see 12 marks. Profit is a measure. When it comes to the view, it is automatically aggregated. There's a default aggregation method applied. Order date and category, they are dimensions. When they come to the view, the members, the values of those 2 dimensions are used as column or row headers or as labels. Further, dimensions define how measures are aggregated. If I undo twice from this one number, if I add order date, then this sum of profit is aggregated by year. After I add category, the profit is aggregated by year and by product category. In other words, dimensions define the granularity of aggregation. Just by nature, for this text table of numbers, it is hard to see patterns, data trend, or compare data across product categories. At the upper right corner, there's a Show Me menu. Click on it. It lists 24 common chart types. It is not a comprehensive list of charts you can create with Tableau, just 24 common chart types. The one that is highlighted with orange color is recommended by Tableau based on the data in the view. So click on it, we got a line chart. Line chart is good to see changes in data value over time. That means it's good to see data trend. We have order date in the view. That is a date field, and that's why line chart is recommended. You can click to select horizontal bar chart. Bar chart is good for data comparison. You can compare profit across product category within each year, or you can click stack bar chart. So you can compare profit across years, and within each year, you can also see the details information about profit for each product category. Or you can select side-by-side bar chart, or circle chart, or pie chart. When I mouse over scatter plot, it's grayed out. That's because this chart type is not applicable. The same for histogram. So when a chart is not applicable, it is grayed out. And I can click on the text table, go back to the original view. So that's a quick demonstration about Tableau's drag and drop feature and how to use the Show Me menu. I will use Clear Sheet button on the toolbar to delete all the data in the view. And then we'll start doing the hands-on activities together. I highly encourage you to follow along. We are analyzing sample superstore data. First, we might be interested to see how profit looks over years. In other words, profit trend. So we need to bring profit into the view. I can drag profit and drop it to the view area, or I can drop profit to rows. If I drop profit to the view area, I'm creating a view from tabular perspective. I'm creating a text table or a crosstab. If I undo, if I drag profit and drop it to rows, I'm creating the view from a chart perspective. Since we want to see profit trend over the years, we need to bring in a date field. Drag order date and drop it to columns. We have a line chart. We can click on the T button on the toolbar to show mark labels or hide mark labels by click the T button again. Line chart is good to see changes in data value over time or to see data trend. We have order date in our view, which is a date field. That's why by default, a line chart is created. If you click on Show Me, you will see line chart is recommended by Tableau, just because line chart is good to see changes in data value over time. And that's what we want. We want to see profit change over time, or profit trend over time. Rename the sheet by double click on it, tap in profit by year. Right click over profit by year, choose duplicate from the menu. So we have the worksheet duplicated. At the status bar, we see 4 marks. We know Tableau uses marks to display data. Each mark is a group of data in the data source or a row of data in the data source. So over here, each mark is the sum of the profit for that year. Mark has properties like color, size, or mark type you can change. From this marks card, this drop-down menu, change it to bar chart. Line chart is good to see changes in data value over time. In contrast, bar chart is good to compare data across categories. So for this view, we can compare profit across all the 4 years from 2018 to 2021. From the order date field, click on the drop-down menu and choose month. Now we are comparing profit across month from January to December. We can rename it profit by month. Similarly, we can create a view to show profit by weekday. Click to create a new worksheet. Drag profit to rows. Order date to columns. Change the chart type to bar chart. Change the order date to weekday. And then we can rename the sheet. You can also swap rows and columns on the toolbar. Just click on this button. You can also sort your bars in descending order, in ascending order, using the sorting buttons on the toolbar, or on the profit exit. You can click to sort it in descending order, in ascending order, or the third click to go back to the default sort order. Let's duplicate profit by year. Right-click over this worksheet tab, choose duplicate. We have this line chart duplicated. There are 4 marks for this line chart. We know Tableau uses marks to display data. Mark has chart type, color, size, and properties we can use data to encode to help us visualize data. From this drop-down menu, change the chart type to bar chart. So right now, we have a bar chart. Each bar is a mark. This bar chart allows us to compare profit across the 4 years from 2018 to 2021. What if I want to see the profit for different product category in each year? I can drag category dimension and drop it to color. Instantly, we can see each bar where each mark has been split into 3 marks. Now we have 12 marks. So this is based on the members or values in the category dimension. On the right-hand side, we can see the color legend and also the members or values in this category dimension. So this stacked bar chart allows us to compare profit across years. In addition, it also provides us details about different products' profit in each year. We can change the color legend, go to edit colors, say furniture, it doesn't profit that much. I will use orange color. Office supplies, maybe blue. Technology, maybe brown. So that's my stack bar chart. I can rename this worksheet profit by year stacked bar chart. Right-click over this worksheet and go to duplicate. If I really want to compare profit for different product category in each year, stack bar chart may not be the best option since only technology has the same baseline and it's really hard to compare office supplies and furniture. So click on Show Me and click on this horizontal bar chart. And we got this panel chart. So within each year, you can compare different product categories' profit precisely or easily. So this is called profit by year panel chart. Really, it depends on your need, what you want to get out of your data. The main goal is to compare different product categories' profit in each year or to compare overall profit across years. So you can choose different chart type depending on your purpose. Similarly, we can create a view to show profit over years and how different segment profit in each year. So create a new worksheet, drag profit to rows, order date to columns. We got a line chart. We want to change it to circle chart from the marks drop-down menu. And we want to use segment to color these 4 circle marks. So each mark will be split based on the members in the segment dimension. Drag it and drop it to the color card. Instantly, from the 4 marks, we got 12 marks. On the right-hand side, we can see the members in the segment dimension, and we can edit colors to the way we like it. I'll just leave it the way it is. People are drawn to use circle chart because the varied size of circle can be in proportion of data. That can be very meaningful. Drag profit to size. Now, the size of the circle is in proportion to the sum of profit. We can rename this to profit by year by segment. We can duplicate this worksheet. Again, if our purpose is to compare how different segment profit in each year, we may want to click on Show Me and go to Panel Chart. So with Panel Chart, we can compare different segments in each year. Next, we are going to talk about data hierarchy. We're going to create a basic view with 1 measure and 1 dimension, create a new worksheet, drag profit to rows, order date to columns, change the chart type to bar chart. Order date is a date field. We can also tell this from its data type icon. It looks like a calendar. Date field in Tableau is automatically separated into hierarchies. Back in the view, from the order date field, you will see a plus sign. You can click it to go to next level detail quarter, and you see a plus sign. You can further expand it to go to the next level details. When you see a minus sign, you can click it to collapse it to go to the upper level. So you can drill down or scroll up. You can break down the viz easily. And if there's a level of detail you don't want to see in the view, you can click, say, quarter. That kill and then delete it. And you have year and month. So this is the built-in feature of Tableau. You don't have to do anything to use it. We can also create a custom data hierarchy. From the left-hand side data pane, we see category and subcategory has a hierarchy relationship. Category is high-level information and subcategory is more detailed level information. To form a data hierarchy, you just need to drag the lower level information and drop it to the higher level information. I'll just use the default name. Click OK. Let's create a new worksheet to test our newly formed data hierarchy. Create a new worksheet and drag profit to rows and drag this data hierarchy to column. And we see that plus sign. So we can click to expand it or click on the minus sign to scroll up. I can swap rows and columns. And I can expand it or collapse it. I will name this custom data hierarchy. Next, we are going to talk about how to map your data. Create a new worksheet. If your data set contains geographic data, location data, you can map it. In our sample superstore data set, we have city, country, postal code, state, geographic data. So we will see how we can map it. When your data is connected, each field is assigned a data type, like string, date, number. Each field is also assigned a data row, whether it's a dimension or measure. Dimensions are those fields that hold categorical qualitative data that you cannot aggregate. Measures are those fields that hold quantitative or numeric data that you can aggregate. In addition, if a field is detected to have geographic data, it will be assigned a geographic row. For instance, state contains geographic data. So when you click on this drop-down menu, you will see geographic row is assigned. It's assigned state geographic row. So in terms of data type, state is a string. In terms of measure or dimension, state is a dimension, and it has geographic row. When a field is assigned to have a geographic row, each member in that field will be associated with a latitude and longitude value. So that's why when you bring that field into the view, Tableau knows where to plot that location, how to map that field. Drag state into the view. Instantly, we have this 50 states, actually 49 states, plotted on this US map. Let's color our states with profit. And we can edit color. Say we are going to choose orange, blue, diverging. I'm going to use two-step colors. Blue to indicate profitable states, red to indicate profit losing state. So click OK. Instantly, we know which states are losing profit. I will name this profit by map. Once again, depends on your need. If you want to see profit across states on a map, this is what you want. If you want to compare profit across state precisely, you can duplicate this map and change it to a bar chart. Remember, bar chart is best for comparison. You can sort it in descending order. You can also color the bar chart so you can see which state is the most profitable state and which state is the most profit-losing state. Next, we are going to talk about how to filter data. Filter allows you to focus your analysis on a subset of your data. We are going to create a new worksheet and build a basic view. We want to see how profit looks across product subcategories. Drag profit to rows, subcategory to columns. I like horizontal bars, so I'm going to swap rows and columns. I'm going to sort it in descending order. If I want to focus my analysis on the product subcategories that are making profit, I can directly drag and select the marks in the view. And I can right-click over the selection, choose Keep Only or Exclude. In this case, I want to choose Keep Only. The filter will be added to the filters shelf. I can remove it. Alternatively, I can select labels and hold down Shift key and select the other label. So all labels in between will be selected. I will choose Exclude. Similarly, a filter has been added to the filter shelf. I can remove this filter from the drop-down menu. Or you can drag subcategory directly to the filters shelf, and you can define how you want to filter your data. I'll just choose General, select from List, and click OK. From the Filter drop-down menu, I will choose Show Filter. When you choose to show filter, you allow end users to modify filter selections. Say, if I want to focus my analysis on the profit-making subcategories, I can uncheck Table, Supplies, and Bookcases. So my data has been filtered. Only profit-making subcategories have been kept. Alternatively, I can select All, and then all data is back. So when a filter is shown, this filter adds more interactivity to the view you have created. Now let's see how to create a dashboard. Click on New Dashboard, the middle button. A dashboard is a collection of multiple worksheets. It allows you to view, monitor, and compare more data at one place. First, you can set up the size of your dashboard. Click on the drop-down menu. I will choose Fixed Size, 1024 by 768. And you will see all the worksheets you have created so far. Worksheet is a basic building block for your data visualization. Each worksheet can only contain one data visualization, one chart. Assume I want to analyze profit information. I want to see more data about profit. I can put two or more sheets together, say profit by year, by product category. I will drag it and drop it to the dashboard. And I can drag profit by year by segment to the dashboard again. Before I release my mouse button, you will see the semi-transparent look of the area. That means that's the place I can drop my second worksheet. I will drop it below the first worksheet. So now I can see profit information by year, by product category, and by segment. In order to make more room for dashboard, I'm going to close the color legend, remove the color legend, the size legend. And also we see the segment, the color for segment is similar to the color for category. So I'm going to go to this worksheet and change the color, edit colors. I'm going to choose Tableau 20 and consumer be purple, corporate maybe this color, and home office maybe this red. Just click OK and back to my dashboard. So we can differentiate product category from segment. Check show dashboard title. I can rename the dashboard as profit analysis dashboard. Click OK. So a dashboard is a collection of worksheets. A dashboard is also all about interactivity. Interactivity between worksheets and interactivity for your end users. So first, if I want the top worksheet to filter the bottom worksheet, in other words, the top worksheet will drive the bottom worksheet, where when I click on 2020, the bottom sheet will be filtered accordingly. So to do that, I can turn on this funnel icon. When I mouse over, it says use as filter. When I click it, it will become a solid white. So that means right now, the top sheet is a filter to the bottom sheet. So if I click on 2020, you will see the bottom sheet is filtered accordingly. If I want to choose technology across all the 4 years, then I have to click and hold down Command key on Mac or Control key on PC to make the selections. That's kind of not convenient. We are going to create a filter that allows us to select a product category. That will add more interactivity to this dashboard. Click to select the top worksheet from its drop-down menu. Go to Filters, Category. Select the product category filter we just created from its drop-down menu. Choose Floating. That means you can place the filter wherever you want on the dashboard. Choose Single Value Drop Down so the filter's size can be smaller. You want your filter title to start with a verb so your end user knows it's a filter they can interact with. Now when we select furniture or office supplies, we see only the top sheet is filtered. That's because the filter is only applied to the top worksheet. From the filter drop-down menu, go to Apply to Worksheets, Selected Worksheets. Check Select All on Dashboard and click OK. Now, when we select Furniture, we see both worksheets have been filtered. Where Office Supply, both sheets have been affected, filtered. That's what we want. Back to the default setting. And we can change the dashboard appearance. Say, select the top sheet and go to hide title, and the bottom sheet and hide title. On the right hand side, I can remove this blank column from the dashboard. I can drag this filter to wherever I want. So this is our profit analysis dashboard. On this dashboard, there are two interactivities. First, the top sheet is a filter to the bottom sheet. So if I select 2020, the bottom sheet has been filtered to show data in 2020 as well. Click to deselect that selection. And the second interactivity is this interactive filter. If I select furniture product category, both sheets have been filtered properly. Next, we will see how to use Tableau's built-in story feature. Click on New Story, the third button, to create a new story. Story is Tableau's built-in presentation tool, so you don't have to step out of Tableau to present your data story. Once a story is created, you can just drag and drop to add a story point. Say, profit by year. Click the blank button to add a new story point. Say, profit by year by product category. A new story point. The dashboard. You can add captions, and once you have put together your data analysis story, you can go to the presentation mode, and you can use the arrows to navigate your story point. We are using Tableau Public. The biggest limitation about using Tableau Public is you cannot save any work locally. When you go to File, the only option you see is to save your work to Tableau Public server. So click to Save to Tableau Public. You will need to log in with your Tableau Public username and password and give your workbook a name and click on Save. This will take you to the Tableau Public server website. Click on the gear icon, Settings. You can turn on Show Sheets. This will list all your worksheets, dashboard, and story as a tab on top, so you can easily navigate it. If you don't have any security sensitive or confidential data, you can allow access. That means people can see your viz and also can see and download your underlying data. If you don't want people to download your workbook, where you don't want people to see your underlying data, you can turn allow access off. Since I don't have any confidential data or security sensitive data, I'll just turn it on. If you scroll down, you can also edit details to change some metadata about this viz. You can share your viz. This is the embed code. You can embed your viz to your website, and this is the link to your viz. You can share it to your friends or whoever you want to share with. A quick recap about what we have covered in today's workshop. we have covered how to connect to your Excel data, how to create basic views with worksheets. We have talked about how to create line chart, bar chart, circle chart, stack bar chart, pie chart, and with the created worksheets on basic views, how to create interactive dashboard, and how to save your work to the Tableau Public server. Two very important concepts, dimensions and measures. Dimensions are fields that hold categorical information that cannot be aggregated. Measures are those fields that hold numeric or quantitative values that can be aggregated. Measures come to the view automatically aggregated. Dimensions come to the view as themselves. They are used as column or row headers or labels. Dimensions defines how measures are aggregated. Dimensions define the granularity of aggregation. So dimensions and measures together, they build up your view. Back to Tableau, if we create a new worksheet, like build a basic view, profit, order date, I can change the mark type to bar chart. I can drill down or scroll up. I can drill down, and I can remove the level of detail I don't need, just delete it. I can also drag and rearrange dimensions on the columns shelf. So we have seen how to use Tableau's drag and drop feature to build a view quickly. So when you drag and drop dimensions or measures to the view area or to the columns or rows shelf, you are building a visual query language. And behind the scene, Tableau will translate that visual query language to SQL, structured query language. That is a text-based query language. And that SQL will be sent to the database, and the database will return a data set based on the query, and Tableau will construct a view based on the returned data set. So that's kind of the cycle to create a view within Tableau. So what you drag and drop, and in which order you drag and drop, and where you drop, all matters, since you are constructing a query language. And that visual query language will be translated to structured query language. So what you drag and drop, and where you drop, and in which order you drop, all matters. So that's the end of this introduction to Tableau Public workshop. Have fun learning Tableau.